Hi there. In this video we're going to be looking at how we can find the determinant of a matrix and the inverse of a matrix. By the time you're watching this video, I hope you've watched part 1 where we talk about the basics of matrices, things like the order of a matrix and other important information like addition, subtraction and simple matrix operations. To find the determinant, you need to be able to know what a matrix is. For example, here you can have a matrix with the numbers 1. This matrix can be said to have the order of 2 by 2 because it's got 2 rows. This here is the first row, this is the second row, then this is the first column and the second column. Whenever I want to find the determinant of a matrix, most of the times we'll be given a 2 by 2 matrix if we're doing syllabus team, but that does not mean we cannot have the determinant for a matrix that is a 3 by 3. Say this was a matrix, this is a 3 by 3 matrix. We can also find the determinant of this matrix. However, our focus for syllabus T is going to be our 2 by 2 matrix. To find the determinant of a matrix for a 2 by 2, we simply multiply this element with this one, 1 by 1, minus the product of this element here and this element. So that will be 3 multiplied by 2. In this case, the determinant of this matrix here is going to be simply 1 minus 6, which is minus 5. In most cases, you will find that the way in which we find the determinant is symbolized in form of letters. So we can have a matrix with elements as letters A, B, C, and then D. The determinant of this matrix, we can also use some symbols. So if we say this is matrix A, when we want to find the determinant, we can write it using this notation. So we've got 2 vertical bars, a letter, which is the matrix that we've been given. This will be equal to A multiplied by D minus B, C. So whenever I want to find the determinant of a matrix, we can remember this simple formula. If you know a bit more about matrices, you could think of it as multiplying the 2 numbers that are in the major diagonal and then subtracting off the product of the remaining diagonal. With that said and done, now let's talk about another thing that will be important. We said we'll also be finding the inverse of a matrix in this video. How do we find the inverse? So to find the inverse of a matrix, what you need to remember is a formula. Usually the inverse of a matrix will be denoted by this kind of notation. What this means when we're working with matrices is inverse of A. Since it's a matrix, it's good at saying inverse of matrix A. So if we're given a matrix, for example, A is equal to a very simple matrix, let's say we have 1, we can put a 3 maybe there so that the numbers are not so much the same. If we have a matrix A, finding its inverse, we will need the determinant, and then you are supposed to multiply this determinant by the adjoint. So if we say our matrix is 1, 2, 1, 3, our adjoint is going to be swapping the major diagonal elements. So we'll have a 3, we'll have a 1, and then we'll give these other 2, the 1 and the 2, negative signs. There's a natural procedure that is used to form this adjoint. However, mostly for your syllabus D, you just need to remember this formula. Now, working with numbers can be a bit tricky, so let's incorporate some letters. So if we said the matrix A is made up of elements that are A, B, C, D, how does the adjoint look like? The adjoint will look like this. Element D will get into this place, element A will be here, then element B will be given a negative sign, element C will also be given a negative sign. When we do this, we have the adjoint, and when we get the adjoint, multiply it with 1 over the determinant of the matrix, we are going to have our inverse. Now, we've talked about these things as formulas. Let's look at the questions that are going to help us understand how this procedure is done. The first question we're going to look at is from the 2021 paper 2. This is the exam question 5A. If you have the physical paper, you can verify the question we're talking about. As you can see from the question, we are kind of not asked directly about calculating the determinant. It's coined in an indirect way. We've been given a matrix that is P. Matrix P is equal to 1, a 2, and a negative x. And we're told that the determinant of matrix P is negative 3. So we're told that the determinant of P is equal to negative 3. Now, we know how to find the determinant. We said we will multiply this element here with the element here and then subtract it. You will subtract the product of these other elements. So from here, what we can do is we can form an equation. We will say 1 multiplied by negative x minus, you can say this is also the determinant, 2 multiplied by 2. So this gives us that the determinant is also equal to negative x minus 4, which will give us negative x minus 4 is equal to negative 3. We can decide to solve this anyway. We can say this negative 4 crosses over to the right hand side, and then we have a positive 4 minus a 3. This in turn will give us a negative x being equal to 1. Therefore, when we divide both sides by negative 1, we're going to find out that x is equal to negative 1. So this here is the value of x. And after you find this value of x, it's not a problem. You could also put some information saying what the matrix now is. P, as you see, is 1, a 2, another 2, and you need to be careful here. And then we have a negative x, so we have negative 1. This is important to write because you know you're going to be finding the inverse of P. So in whichever case, you're going to find this matrix P. So now, since we have the matrix P, we can now go ahead with finding the inverse of P. If you can remember how we are supposed to find the inverse of P, the first thing is we're supposed to find the determinant, but we already have the determinant, so we need to find the adjoint. And if you can remember, we said that inverse of a matrix is equal to 1 divided by the determinant of that matrix multiplied by the adjoint. Adjoint sometimes can just be shortened as that, and then we can also put something like this. Another way you could see this formula sometimes, it shouldn't confuse you. You can also see it written as DET and the name of the matrix inside brackets multiplied by the adjoint of P. These two things here mean the same thing. Now, we know that the determinant is negative 3. If we scroll up, this was what we were given in the question. So the next thing we only need to find is the adjoint. So if you've forgotten what the matrix P is, you can write it somewhere. It was 2, 2, and a positive 1. This matrix here. Notice I've simplified the negative multiplied by the negative, which gives us a 1. So the adjoint, like we said, for a 2 by 2 matrix, we're going to swap these two here, the 1 and the 1, but that changes nothing. Usually I like starting like this, then we're going to make these others negative. So we have negative 2, meaning the inverse of P is going to be equal to 1 over, we have a negative 3, then we have a 1 here, a negative 2, a negative 2, and another 1. This is our final answer. Some people will be okay with you leaving your answer like this, or you can further include fractions inside, but since you know how basic matrix operations are, you easily know that this 1 over 3 will multiply by each of them. Sometimes I avoid writing this fraction inside here because they'll eat up some space. You need to notice we have a negative, so some of these will become positives, and this will be our final answer if you like. You can choose to write it like this or write it this other way. It should both be correct. With the first question done, we now know what we are expected, and I will kind of just go through the other questions to get you comfortable with what you're supposed to do. If you've gotten the idea, I would encourage you to pause the video, try this question, and see whether we'll have the same answer. The first thing we're going to do for our question here is find the value of x. We've been given a matrix which is K, and this matrix K is 8, 9, x, 1, and x. We have been given that the determinant of this matrix K is equal to 2. So what we're going to do is use the formula definition of the determinant, which is going to mean we'll multiply the 8 multiplied by the x minus the 1 multiplied by Vx. If you remember earlier in this video, we said the determinant of the matrix, usually you can say, is equal to A D minus BC. Given that A is a matrix which is in this form, like this. In books, you might see these letters arranged in a different way, which will in turn change this formula. So it doesn't matter the formula you're using, but the actual process that you're following. So we have written formula definition here. So we have 8x minus 9x. What we see is our determinant using the elements in our matrix gives us negative x. Now, since we have two definitions of our determinant, one says the determinant is 2 and the other says the determinant is equal to negative x, what we are going to do is equate both of them. So negative x is going to be equal to 2, and this is very easy to work out. We'll just divide both sides by negative 1 to have the positive value of x, and x is going to be negative 2. Now, since we have x, we can easily write our matrix K. Our matrix K is going to be 8, 9 multiplied by negative, and we'll have a 1 here and a negative 2. This here is our value of K, the matrix. Next, we're asked to find the inverse of K. Since we have our matrix K already, the inverse shouldn't be difficult. We'll just write the definition of the inverse. So the inverse of a matrix K should be equal to the determinant of that matrix, which have already been given, multiplied by the adjoint. We already have the determinant. What is only left is finding the adjoint. So we'll do that first. The adjoint of K is equal to, we swap the position of the 8 and the negative 2. So we have a negative 2 here, we have an 8. Then on these other two elements that are left, we'll multiply them by negative, meaning we're going to have 18 and a negative 1. This is our adjoint, and now we can easily find our inverse. we've been given the determinant as 2, so we simply just multiply this like this: 18, -1, and 8. Here we have a case where most of our numbers in the matrix, or the elements of our matrix, are divisible by 2. These are one of those rare cases where I'm going to multiply each of the elements by the number outside, which is usually a fraction. In this case, we'll have a negative like that, we'll have a 9, and at least we'll just have one fraction. All the other numbers, as you can see, can easily be written. In such a case, I would advise you simplify, because there's only one part there, which is going to be a fraction. However, both this step here and this one here should be answers that give you the full marks. Here's another question. We have more and more algebraic expression appearing. The previous one had 2 algebraic terms. This time we have an algebraic expression part of the elements in the matrix Q. We've been told matrix Q has a determinant of 15. If you read the question, we are asked to find the value of B. So we'll do the same thing we've been doing, it's just that now we'll be doing a bit of more algebra. And speaking of algebra, we have some videos about algebra. We start from the basics and we do the same thing for algebra as we are doing here. We look at the various concepts that you're supposed to understand and then explain them to you through questions. So be sure to check those videos about algebra too. We have been given that our determinant for Q is 15, so that will be valuable information. We can just refer to this matrix here. Usually when you get comfortable, you don't have to keep rewriting a lot of things. And then we can say also this same determinant Q is equal to 2b minus 1, and then we can put some brackets here and there. So we get this first one and multiply it by the -5. Then we're going to subtract -3b multiplied by 4. If we work this out a little more with algebra, we can know that this 5 is going to be distributed, or when we're expanding, this 5 will multiply by each of the elements here. So we have a -5 multiplied by a 2b. We also have a -5 multiplied by a -1. Then for this one here, it's simple. We already have a positive because the negative and the negative are multiplying. Then we have a 3 multiplying by a 4, which gives us a 12. So we'll have a 12b. So here we have a -10. We have a +5 and a +12b. We can see that we've got 2 terms that have got b. So we add those 2 terms together, or you could also think of this as subtraction. 12b minus 10b, which gives us 2b. So our determinant is also equal to 2b plus 5. Now, using the 2 forms of our determinant, we can combine and form an algebraic equation, which is 2b plus 5 equal to 15. With this algebraic expression, we can make 2b or b the subject of the formula. This 5 will go to the right hand side, meaning it will be 15 minus 5. And then we can continue and say 2b is equal to 10. And then finally, we can divide both sides by 2. 2 into 2 is 1, and 2 into 10 is 5. Therefore, b is equal to 5. With this information, it can be good for you to write the matrix Q in its actual terms. but we'll do that in part 2 of the question so that we don't waste a lot of time. That can also be another alternative. So Q, from the description that we were given, it's 2b minus 1, and we have 4, negative 3b, and negative 5. These are the elements of Q, but we know the value of b is that, so this means the matrix Q can be written as 2 multiplied by 5, which is 10, 10 minus 1, which is 9. Then we have a 4, a 5 multiplied by negative 3 will give us a negative 15, and there we have a negative 5. This will be the matrix Q. You can pause the video, try to go through these steps by step. Then what we need is the adjoint. If you can remember, we said to find the inverse of any matrix, we need two things. One which we have already been given, the determinant, multiplied by the adjoint. So since we have the determinant, what we only need is the adjoint. The adjoint of Q is found by swapping the elements in the major diagonal. So we swap this 9 and the negative 5 like this. Then we have a negative 4 and a positive 15. Remember, for those elements in the minor diagonal, the 4 and the negative 15, we multiply them by a negative 1. With this information, now we are able to calculate for the inverse of Q. If you can remember, our determinant was 15, and now we have the adjoint, have negative 5, a negative 4, a 15, the 9. Obviously, we can do some simplification for some of these numbers. For example, we know 5 over 15 can be simplified to a smaller fraction. However, because we have numbers, a number like 4 here, which won't be very easy to simplify into a fraction that will have a common number with the others, it's best you can leave your answer here. But if you don't mind doing some extra work, you can actually take the work further. So this here can become negative 1 over 3, and this here will be negative 4 over 15. Here we're going to have a 1, and there we're going to have a 3 over 5. These numbers here coming when we multiply this by that. So 5 into 5 is 1, 5 into 15 is 3. 3 can go into 9 3 times, and 3 can go into 15 5 times. This is how these numbers here come about. So you could also leave your answer in this simplified form, or you can also just leave it in this form. Some teachers actually prefer that you just leave it like this because it looks much more tidy for most people. However, you can also arrange your answer like that. With all the questions we've done so far, you are ready to answer any question that requires you to answer for the inverse of a matrix or calculate the determinant. Here I just made a bonus question for you to do some practice in your algebra. Remember, I kept talking about the algebra playlist. The algebra videos, they should be 3. We have a part 1, part 2, and part 3 where we talk about everything about algebra that you need to know for syllabus D exam. In this question here, we're going to also work with some algebra. As you can see, it's not from a past paper question, it's just a question that's made for those people who reach the end. We have a matrix Z in this case. Matrix Z has the elements x, 1, 8x, and 4x. The determinant of this matrix is negative 4, and we're asked to find the value of x, after which we can find the inverse of the matrix Z. Let's start with finding x. So when you look at this question, it kind of just looks simple, but for most people it might be challenging unless you do a lot of math. We also know the determinant can be found by multiplying the 4, the x, and then subtracting the product of 8x and 1. So determinant of z is 4x squared minus 8x, which is also equal to the negative 4. So we have 4x squared minus 8x is equal to negative 4. What would you do if this question was found in your exam? Well, if you've watched our videos about algebra, this one beats you so much. What you have to do here is bring this negative 4 to the left hand side and form a quadratic expression or a quadratic equation. Then we will be required to utilize one of the methods that we talked about in those videos. We will solve this quadratic expression by factorization method, one of the methods that we can use. So here, what do? Well, from the look of how our expression looks, we have a 4, an 8, and another 4. We can factor out a 4. Remember, it's factorization method that we're going to use. So try to see some more factors. We have a 2 there, we have a 1, which will be equal to 0. Now, because we have a 4 being multiplied by this whole thing here, in mathematics, it's possible that we can divide both sides of the equation by the number which is being multiplied on one of the sides. We do this most of the times. So the 4 there will cancel, and 0 divided by 4 will just give us 0. So our simplified expression that we're working with is x squared minus 2x plus 1, which will be equal to 0. Now, with this, we can apply the factorization method. To apply the factorization method, we need some important information. We need a product. The product is the multiplication of the number that is in front of the x squared term. Usually, a quadratic expression will be in the form of ax squared plus bx plus c equal to 0. So to find the product, we multiply a and c. So the number that is multiplied by the x squared term, which is 1, and then multiplied by c. C is also 1. So our product is going to be 1. Our sum is going to be the b term, which is negative 2. Then our factors are going to be two numbers that if we multiply will give us the product. If we add them, we're going to get the sum. Those numbers are not difficult in this case. It's negative 1 and negative 1. Multiply these two, you have a positive 1. Add them, you have a negative 2. With that said, now we can rewrite this algebraic expression like this. And then where we had the b term, we can replace with the sum of the factors. What that means is we'll have plus negative 1 plus negative 1 multiplied by x like that to be equal to 0. This usually is skipped in most solutions, but I like including it so that you just get what's happening. Now we're going to group these terms. So we have x. When we get these two terms here, the first ones, we group them, we find what's common. We do the same even for the other ones. Here it's a bit difficult to see what's common, but what you need to remember always is when you don't see anything common, try to think of 1. Can 1 be part of both terms? Actually it can. If we factor out a negative 1, we have x minus 1, which is equal to 0. Now you might be asking, what if we factored out a positive 1? Well, you could also do that, but then you will not be able to have an answer after that. The guiding principle here when you're doing the factorization or the grouping is that what you have in the brackets should be the same. If you put a positive 1 here, you end up having a negative x plus 1. In that case, what's in the brackets here and what's in these brackets is not going to be the same. They need to be the same because after this we need to do another factorizing. So if we factorize x minus 1 from this part, the left hand side, what are we left with? Here in this term we're left with an x, and here in this term we're left with a -1. This is why these brackets are supposed to match, so that you can continue with factorization. After we have done all the factorization, we remain with just two multiplied expressions like this. Now to find the value of x, what we do is equate each of these, the x minus 1 equate it to 0, and this other x minus 1 equate it to 0. Since both expressions are x minus 1, we're just going to have x minus 1 is equal to 0, which means that x is equal to 1. This is the value of x that we need to put in these positions for us to have the matrix Z. You can see it's a bit more about algebra. Next, let's see how we can find the inverse. Finding the inverse again here is not something difficult. We have our matrix Z. The next is we need to find the adjoint of matrix Z. That is going to be 4, 1, -1, -8. Meaning the inverse of Z is going to be 1 over the determinant of Z, which we have, multiplied by the adjoint of Z. Our final answer is 1 over, what was our determinant? Our determinant was -4. In this case, you would leave your answer here, or you'd simplify further to -1 to 1 over 4, -1 over 4. Both answers should give you full marks. That's it that I had for you for matrices. Hope you enjoyed the few questions that were selected and now are ready for undertaking any question about matrices that requires you to find the determinant and the inverse of a matrix.